Can you count out of 34?
Oh, 9.
But even so, it's the same. 30, 34. You can't get to that next 9 until you get to 36 because 4 times 9 is 36.
Yeah.
So right there's your first one. So what's 3 times 9?
3 times 9, right? 27.
Okay, so that's what you're dividing by 9, right?
Yeah.
Okay, so now you got to keep track. You got to take 36 as we're counting how many 9s are in 360, right? Okay, so now we figured out it's 20. It's actually that 3 is 30, right? So it's actually 270. So anyway, take 360, subtract the 270. And what do you get?
360 minus 300.
That's right, 340. What was it? It was 340. Sorry.
Yeah. 360 minus 340.
Nah, wow. Now, see, now we're all confused because we took too long and I had to start the recording. Nope. Okay, start again. What we did, we take 100.
Yep.
We subtract 32.
68. 68
Multiply by 5.
times 5 over 9.
Just multiply by 5 first.
Okay. And then...
Wait, just multiply by 5. What do you get?
340.
Okay, there's a 340. Okay, and then what I said, how many 9s in 340? Well, so far we figured out there's 30 of them. So 3 times 9 is 27. Put the 0, because it's actually, you don't have to if you're just doing shorthand. But 340 minus 270 is how much?
340 minus 270 is...
Oh, come on. David, you don't know what the answer is? Why don't you do it in your head?
70.
70.
670.
Yeah. But it's just 70. Okay. So how many 9s in 70, David?
How many 9s in 70? 9.
Mm-hmm.
Six.
I think there's more than that.
Oh, no, there's 7 and there's a remainder.
7 with a remainder. There you go. So, okay, right there, you know that conversion means that 100, like I said, is 37 degrees, right? Now you can do the next 2 digits if you want to.
Is it 63 and 7? Oh, no.
So you had, right, so you had 70, so you had 7 left. So what's it going to be every time?
Wait. Is it 7 and 7 out of 9?
7 and 7 and 7, because every time you do 7, it's going to be 70, and then you're going to do 63, and then you're going to do subtraction, and it's going to be 7 again, and then you're going to do 63, and then it's going to be 7 again. So it's what's it going to be? It's going to be 37.77.
7.
And you could put a line over it that says it's going to repeat, right? Because it's going to be 7 forever. Because you're dividing by 9. 9 does that.
7.
All right, so let's do another one. David, you're on.
Okay.
That was 100.
Can you do the thing like...
Let's do 90.
Someone went to a cake...
A donut factory?
A cake factory.
A cake factory. We'll do a cake factory. Okay, yes. But first, yes, absolutely. But first, see, they ask for pre-calculus. They ask for it. First, do 90.
So I write down 90.
So write down 90. Subtract 32. Multiply by 5. Divide by 9.
So 90.
So what you're doing is converting from Fahrenheit to Celsius.
Subtract sign again.
Subtract 32.
So minus 30.
What will you have? 90 minus 30 is already 60, so it must be 58. Okay, now you got to take your 58 instead of 68, multiply by 5. What you're going to get? 290.
What is time?
58
multiplied by 5.
Yes.
How many?
That's what I'm asking you. How many?
5.
5 times 58. What's the number? 58 5 times, or 5 58 times.
5.
And you can do it, but oh my God, it will take you forever. 5, 10, 15, 20, 25, 30, 58 times. No, we're not doing that. That takes too long.
You know 100 is 25.
Oh, I like that.
Wait, so 200 is 45.
100 multiplied by 5.
100.
So we know 58. 5 times 5 is 25, which would be 250. And 5 times 8 is 40. So it would be 290. What? I'm done. What are you guys doing?
5 is 1. 5. Then 1 time. Is that possible? David.
Yes, it is possible to go faster, and I just showed you. Count the big ones first, young lady.
Oh, oops.
So 5 times 5, what is that? That's actually 5 times 50, so that's 250. And then 5 times 8 is 40, and you got to add your 40 and your 250. No big deal, because you know that 4 and 5 is 9. So what do you have? You have 290. Now you got to divide by 9. So what's the most? It's 3 again.
290?
Yes. Now divide that by 9.
Oh, okay.
Yeah.
Wait.
How many 9s in 290?
Divide it by 9.
Show me your work. I want to see what you're writing down. I can't see what you're writing.
Wait. What is that?
I like it. Yeah, right there. There you go. Okay, so you're writing it with the division sign. Okay.
What is that? Okay, this is called long division.
It's called long. Yeah, it's actually easy long division though.
But then, like, so 9, you can't do.
You want me to show you on the board?
I've done it before, but you can't do 2, so you have to take 29, so 9, 18, 20.
Okay, hold on. You guys, holy cow! All right.
3, 27 was minus 7. So then you bring it down. Then 9, 18, 20.
Oh.
2.
Oh, let's get some light on this situation.
2. So your answer will be 32. Your remainder here, 2 over 9, because it was 6.
So what do we do? First, we took 90,
Mm-hmm.
and then we subtracted 32, and that gave me 58. And then I multiplied 50. Well, it's supposed to be a 5.
Is that correct?
And then I multiplied, isn't it? Oh, make some noise.
Is that correct?
Yes. I'll take it. All right, look. And so what do you have? Then when I multiply that by 5, right?
I'll show you how to do that. I don't think David knows how to do long division.
It's okay. 290. I'll show you. So here's what we're going to do. David, you got to look in your mind. You got to think about it like this. This 290. All I'm doing is seeing how many 9s. So that's how far across it has to be. So this has to be 9 across, and then everything else has to go down here. So I wouldn't be able to use this. I'd have to break it up and make it so that it's only 9 across. And if I did that, what's going to happen is I'm going to have that, right? And then there's going to be some down here. Oh, one more. Like that. Okay. So what is that? That's 30, right? Because you said 3 times 9 is 27. Oh, we were pretty close. But that's not 3. That's 30. That's 10, 10, 10. Which is what? Well, if this is 9 and this is 10, that's 90, 90, 90, 270. What would be left? Well, 20.
0.
Oh, wait a second. I had 290. I only took away 270.
20.
So what would be left? Well, you'd be 0 here, but I don't have to write that. That's silly. And it would be 0 here. What's 9 minus 7?
9, 2.
All right. Now, how many 9s in, right? How many 9s in
20.
20? Well, that's easy. All right, so right there, you already know 90 degrees Fahrenheit is 32 Celsius. And if you want to keep going, what's going to happen? It's going to be 2, 2, 2. So what are we going to have? It's going to be 32, 2, 2, right?
32, 2, 2.
Because no matter what, it's always going to be 2, 2, 2, right? Or, like she said, 32 and 2 ninths. Right? Make sense?
Yeah.
Okay, you want to go the other way?
Yeah. Can we do
All right, okay, so what we want to do is, if I start with Celsius, how do I get to Fahrenheit?
Oh. Okay, wait. Is it the opposite?
It's almost an opposite. It's the inverse, actually.
Oh, okay.
So let's think about it. How would we do that? Let's think algebra. So over here, I have X, right?
Yeah.
Whatever X is the temperature. So, and I'm trying to find Celsius. So over here, I'd have to say X minus 32 times
5.
I could get crazy about this if I want to do some algebra. I could say 5 over here and then go by 9, right?
Yeah.
Technically. Or I think the way you were writing it was in a straight line, X minus 32, whatever the temperature is, times 5 ninths. Right?
Oh, yeah.
Okay, so how am I going to get Celsius? Because what does this equal? When I do this, this gives me C. And I should make this, I shouldn't say X. Let's make this F, Fahrenheit.
F minus 32.
Yep.
5
Equals C.
equals C. But then from C to F,
So now how am I going to get 32 all by itself?
C divided by 5 ninths.
Mm-hmm. Here's what I'm going to do. Algebra is what I'm going to do. Because you know what? This is no fun. Get back to 1. So you know what I'm going to do? I'm going to multiply this by 9 over 5. That's called a reciprocal. Why? Because then this times that is 1, right? So now, if I multiply that by the reciprocal, I got to multiply everything, not just this one. So now I have 9 over 5, which is the same thing as 1 4/5, right? Oh, okay. So 9 over 5, C is the same thing as F minus 32. So now what I got to do? I want to get F by itself. So I'm going to have to add 32 to both sides to get 0, right? Here is 0. What do I need? I need here is 0. Because I have F minus 32. So what I'm going to do? I'm going to add 32. And then I'm going to add what? Because 0 is over here. And what is 0? 0 is 32 minus 32. That's my 0. So I take away the negative 32s. And I have a positive 32 over here. So now I can say, what is this? This is 1 point. Well, actually, let's leave it in fractions. 1 in and what? How many 5s in 9? 1. What's left? 4. What was I counting by? 5s. Multiply by C. Add the 32. And lo and behold, I will get Fahrenheit.
Oh,
Shall we check? Let's check.
it is the formula is David. Let me get my.
So here's what I'm going to do. I'm going to tell you, David. David.
Sorry, just.
I'm going to tell you that C is 37.77.
Yes.
Yeah, I'm gonna tell you that. I'll tell you what. I'll make it even better. 37 and 7. Oops, not point and 7/9. There you go. Now you got some fractions to do. And then we can go to the donut factory or the cake factory.
Cake
What
factory.
What kind of cake? Cheesecake?
Nope. Ice cream cake.
Ice cream cake. Okay, we're gonna have an ice cream cake factory. I like it.
Wait. So the formula, I have to make sure, is C times 9/5.
Okay, fine.
C.
But wait a minute. That's not yet. I have to add the 32. Don't forget the 32.
Wait.
So let me put plus 32 is the same thing as that. These are the same. One is improper fraction. One is a mixed number.
So the first step is to plus 30.
Yep, and see, and this one, yeah, we could do it two ways. We could do it in decimals. What's 4/5 in a decimal? Can you do it? Can you change 4/5 to a decimal? Don't feel bad if you can't. 90% of Americans can't do it either.
Wait, I can, but I haven't done it in a long time. Wait.
Okay, hold on. David.
I have to change it to a 10. So 5 times 2.
Okay, I'll take it.
Wait, 5 times
You know what I would do? I wouldn't just take it. I wouldn't do 2. I would do 20. Why? Because I want 100.
Yeah.
So 20 times 5 is 100. 20 times 4 is 80. What's 81/100ths?
81/100ths is.
How do I write that?
81/100ths is at least a few thousand.
Okay, or I could say it's 8/10ths.
8/10 is 80.
8/10ths is 80. 8 times 10 is 80. 8
10
tens is 80. But this is 8 divided by 10.
8 divided by 10. Wait, is it?
So look, isn't this just 0.8? Isn't that 8/10ths right there?
0.80.
0.80. 0.8. Okay, I'll take it. Goodness gracious, why you have to say all of that? I would just 0.8. You're correct. You're more correct than me when you get down to it. Because look at everything that you said. You said 0.80, and I'm lazy over here just saying 0.8. We're both correct. Okay, so now I can, like I said, in fractions, I can say I'm going to take this now that I can convert. That this is going to be 1.8 times C plus 32 will give me Fahrenheit. How's that? Okay, so like I said, I'm telling you that C, David, you're on. I'm telling you that C equals 37.77 or 37 7/9. You tell me what's F if this is C.
See what's F?
Dun.
See what's F?
Yeah, tell me what I told you what C is. I told you this is the temperature 37.77 degrees Celsius. What is that in Fahrenheit?
Fahrenheit.
You have the formula right here. You're gonna have to do some math.
Okay, give me.
Big sister, help your goofy little brother figure this out.
Because I've never learned the Fahrenheit and Celsius things.
You're learning it right now.
Great. Bro, David.
All right. So anyway, show your brother what to do. You got to do some math. Oh my goodness. I got to take 1.8 times 37.77. Oh no. Or I got to take 9/5 times 37 7/9. You got some math to do, kids.
Celsius to Fahrenheit.
This is why we invent calculators, and because we don't want to do this kind of stuff. But anyway, just do it once. Let's see if we can get it right, David.
Wait, so the first step we need to do from Celsius to Fahrenheit is you plus 37.77.
No.
Then
What's the first thing that you do? What's C? C is 37.77. So what do you have to do? You have to multiply it by 1.8.
wait,
And then you have to add 32.
C is 37.77, right?
Yes. So now you have to multiply it by 1.8. I'll tell you a trick. If you, instead of multiplying by 1.8, just multiply by 0.8 and add it to 37.77. What do you think?
Am I correct?
What?
Celsius to Fahrenheit. The first step you need to do is times 1.8
Mm-hmm.
and then plus 32.
Yep.
And that's all?
That's all. But you have to multiply 1.8 times 37.77 because that's your Celsius.
Okay, okay.
Okay. Okay, then.
Sorry, yeah. Okay, so my Celsius is 37.77. The first step is times 1 point.
Or you could just, like I said, multiply by 0.8 and add it to the 37.7 because you already know what 1 times 37.77 is.
Yeah.
So what, David? You just got to multiply. 8 times 3, 8 times 7, 8 times 7, 8 times 7, and add them all together.
8 times 7. Yeah.
And then don't forget to move your decimal place 1 over.
It has to be a 2 decimal place, right?
It has to be one, well, just 1 because you're multiplying by 0.8. So if you want to multiply by 8, you'd have to move it over. However you want to do it. Just tell me what's 1.
Oh my gosh! Wait, it's
Wait. What's 1.8 times 37.77? It's not a hard problem. It's not hard.
It's 7.
Nobody.
7.9.
Oh my goodness. All right, so 37.77. We're not even using blocks. And I'm going to multiply that by 0.8.
Is it 67.98?
What do you think? Because here's the thing. Oh, are you talking about the whole number or are you just talking about 0.8?
The answer.
Now, here's the thing. If I multiplied by 2, I'd only have 74. Right?
Yeah.
Okay, so what's 1.8? Well, like I said, I'm not helping you. You're a big girl. You should be able to figure this out. And David, you too. Because look, all you're doing is multiplying by 8. Stop it. All right, so look, punk, I'll do that. And then I'm going to move the decimal point back the other way.
And it's a 0.
Can you, if you want to, but fine. But who cares? What's 8? Now you got to do 8 377 times.
Oh, yeah.
But still what? Just do it.
Okay.
That's 3 times 8.
3 times 8. 24.
Okay, what's hard about that? Nothing. Now, your trick is 24 what? Because what is this? All right, I'll tell you what. Let's move it back. We'll put it back so it's confusing. All right, 0.8, 0.37. What is that? Well, is that going to be, you're going to be over because you're multiplying by a tenth, right? These are 8 tenths. You're not multiplying by 8 whole units. And see, we multiply it however you want. You can multiply it by 8 units, and then you have to move the decimal back, or you can just do this. And I know 8 times 3, that's supposed to be 30, right? 37, actually. Well, this is 24. Of
I'm
that,
trying to see it.
multiplying by 0.8. I'm multiplying by 8/10. This is 8/10 of 30 is 24. Okay, now what? So I'm going to have, I'll put my decimal point right there. And now I'm going to multiply 8 times 7. What's 8 times 7?
8 times 7? 56.
David, what's 8 times 7? You're supposed to know your multiplication tables. Lucky 7 Samson. What is 7 times 8?
56.
Yes, got 56 fingers, right?
Yeah.
Okay. So 56, which is what? That's 5.6. That's not all 7 of them. That's 0.8. That's 8/10 of 7. And then what? We just got to do it 3 more times. So that's easy. 5, 6, right? 5, 6. All right. So now I'm just going to add everybody up. What? What am I get 11s, right?
Oh, yeah.
So here I'm going to get 6, right?
8 times.
I know it's the end is 6. And then over here, I know 2. And then what? I'm going to add 4 and 5 and get 9. But oops, I got an extra one over here. So I have 3, 0, right?
3.
You know what I did? Because this is supposed to be a 6, 5, 6, 5, 6, 5, 6, right? So 24, 25, and 5 more is 29, and 1 more is 30. And then what? I have 30.1. But what? Then I gotta have this one over here, which is a 1. So this has got to be a 2. And this is a 1. Oops, it's got to be a 2. And then you'd have 5, 6, because this would be 7, 7, 7 going forever and ever. And I would have 0.2222222 forever. But let's just go 2 places and we'll call it a day. Right? Okay. Now what?
How can 37? How can it be 37.7,700?
This is 37.77.
Is it 37,000?
Now, wait. We're not done. Now I have to add that because what are we multiplying by? It's supposed to be 1.8. So 37.77. Oh, is 67.99. Right? Right?
Yeah.
And then I got to add 32 to that. And I'm going to get 99.99. And it should be 999. And it was supposed to be 100.
Ooh.
You see it?
Yeah. And then
that's what we did the first one. The very first one, when we first started talking, before we even started filming, is I said, look, you take 100, you take away the 32, right? And then you multiplied by 5/9. So then we went the other way just now, and we got close. We were off by like 1/10 or 1/100th or 1 whatever, right? Because it's 99.9999. Because we're never with these numbers, we're never going to get back 100.
Ooh.
But I can certainly round up, right? Isn't 99.9999999 basically the same thing as 100?
Yeah.
There you go. All right. You want to go to a cake factory?
Yeah.
All right, let's do it.
Lift the paper around. I'm gonna draw a cake.
All right, you're gonna draw a cake. Okay, I'll do it. I'll give you the numbers, and then you got to tell me how much the cake factory is making. Okay? Okay. So since we're making cakes, I'm going to use whole numbers, and they're going to be kind of small because cakes take a little while to make. So his ice cream cake factory. Let's see here.
No, you make it from the start. Take the ice cream, how long it takes to freeze, how many layers, how long each layer takes to freeze. Like some layers can take more time to freeze.
Okay, so what we'll say is that after, and you know Mui, right? Mui never gets there on time. If he would have got there at on time, he would have been able to tell you if there was any to start with, right? But since he didn't get there on time, he tells you that after 3 hours, there are 13 cakes in the factory. And after 5 hours, there are 21 cakes in the factory. How fast are they making cakes? And were there any cakes to start with?
Yeah.
Okay, let's find out. Do it. Tell me. So we want to know what happened at 0 hour. And then let's say we want to know what happens at 8 hours. And then let's say how long, if they got a huge order for ice cream cakes, how long would it take them to make 81 cakes? Somebody ordered 81 cakes and they had to go work and make a whole bunch of ice cream cakes because there was a school that had 81 kids and they all wanted an ice cream cake of their own because they were greedy and they all wanted to get diabetes.
Mm. 0 hour. Is that X? Wait, after 0 hour, I write 3, right?
I don't know. So, what do we have to do? Can you guys remember how to do this?
Okay.
What did I have to do?
So at 3 hours, there were 13.
And after 5 hours, there were 21.
So these.
So what did I have to do? What did I have to do?
How many cakes do they make each hour?
That's what I'm asking. That's what you have to tell me with this information.
If in 3 hours they can make 13, we need to split 13 into threes, which are the same number, right?
Okay, but they might have started with some, so that's a good thing. How many threes can I count out of 13?
3, 6, 9, 12.
That's it, right? So how many? 4. How many fives can I count out of 20? Oh, so it looks like 4 to me. And if I counted 3 4s, there'd be 1 left, right? Because that'd be 12, but I have 13. And if I counted 4 5s, there'd be 20, but I'd have 1 left, right? So they must have started with 1.
Okay.
So y equals, and what did we have to do? We took the difference, dy, the difference between these two. What's the difference between these two? 21 and 13. What's the difference?
The difference is, wait.
See, that's why you got to be able to do it fast and easy in your head.
8.
8. Good answer, because it's correct. All right. Now, what's the difference between 5 and 3? You guys got to be like subtraction and make a difference.
5 and 3? 2.
Yes, simple. So what's 8 divided by 2?
4.
There you go. There's your weight. They make 4 cakes per hour, and they started with 1. How do I know that? Well, because 4x, if I put 3 times 4, I get 12, and I have 13, so I have to add 1. If I had 5, okay, so now how many after 8 hours?
Oh, wait a minute, wait. Y is 4x plus 1.
Yep.
So the formula was for this was like.
All right, so how many after 8? They work for 8 hours. How many did you get?
Okay, wait.
David.
Hmm?
After 8 hours, how many ice cream cakes did they make?
Wait, I need 8 hours. They I get it. Wait, I need help.
What do you need help? What's 4 times 8?
No. I mean, that can you go through the part where you find out how much cakes they make in 1 hour?
Yes. What do I have to do?
4. No.
4.
I
But
don't
how do I know? But she's asking, well, how do we get 4? Right?
Yeah.
Okay. So what I did was I took the difference between these 2 hours.
Yeah.
That's dy, and I
Yeah.
figured out that was 8. And then I took the difference between these 2 hours, right? Because this is the total amount of cakes. This was the amount of time. So I took the difference in y divided by the difference in x, which is 8 divided by 2, and I got 4.
Oh.
And then, so I know y equals 4x. But wait a second. If y equals 4x, then that should be 12. But it's not 12, it's 13. So I have to add.
Okay, wait.
What do I have to add?
You
Vivian,
plus
really? How much more from 12 do I have to add to get to 13?
1.
Well, then,
Oh.
and then if I take 5 times 4, what do I get?
20.
Okay, so if it's 20, but it says 21, how much do I have to add?
1.
There you go. All right, so after 8 hours, how many ice cream cakes did they make?
Oh, 4 every hour, right? Yeah. Every hour they make 4. How many minutes would it take to make each? 33.
33 is the right answer. How many minutes would be 60? Because what? 1 hour is 60 minutes.
How many minutes would it take to make 1 cake?
60. Oh, how many minutes would it take to? Oh, that's a good question. If they make 4 cakes in an hour, how many minutes would it take for each cake? That is a very good question, David.
We do that.
Okay. What do you think?
Okay, 60.
4 cakes in an hour.
How
How
many
many do they make?
4s are there in 60, right?
Okay, I'll do that.
4 times 60. I think that will take too long.
No, wait a second. How many 4s in there? If I count, oh, you're going to count like that. You're right. Counting like this would take too long. So how many would be 10
How
4s?
many?
How many is 10 4s?
How many is 10 4s? 4.
What's 10 times 4?
10 times 4 is 40.
40. Okay. So 10 would be 40. All right. Well, let's see here. What's half of 40? 20. What would that be? What's half of 10? 5. What are we counting? Minutes. So 15 minutes. Right? Because why? Because we're dividing by 60 by 4, and it turns out that 60 divided by 4 is 15.
So each cake would take 15 minutes, right?
Correct. And they started with 1 cake. Now, Vivian.
Yeah.
You're not off the hook yet. How long did it take them to make 81 cakes?
81. Okay. So it takes 15 minutes for each cake, right?
Yeah, but skip that. You know how much they make per hour. Why are you going to do it by a minute?
Oh.
So how are you going to solve it?
Okay, wait.
No, I want to hear it. How are you going to solve it?
Is it 81 times 15?
Not even close. Look over here. What's y in this story over here?
What? 4
What's y? Y is what?
hours.
Y is 81. That's the number of cakes.
Okay.
Now we know that 81 is the same thing as 4 cakes an hour plus 1.
Oh.
So tell me what x is. See, how old are you, David?
9.
See, you can get away with this. I get it's disturbing and upsetting when the child is 16 or 17 and they don't know what to do.
Can we do
When
the
you're 9, okay, David, what does this say right here? This says, what is this? This is X and
Yeah.
this is Y.
X, Y, Y, X?
This is X. Wait, this is X and this is Y. So over here, what? When Y is 1, X is 0,
10
right? Plus 1.
equals
When Y is 3, well, now what? Well, wait. Excuse me. Y is 13. X is still going to be 3. That's the thing that's changing. That's the thing that's varying. We figured out what the rate was, and then we add 1. And what do we get? That's 13. Isn't 13 the same thing as 4 times 3 plus 1? And then I look over here. Oh, 21 is the same thing as 4 times 5 plus 1. And then what? 33. Well, I didn't give you that one. The other one, I gave you 8, and you had to tell me it was 33. And now I'm telling you it's 81, and you have to tell me how long they were working.
they were working for
So
these.
how are you going to solve it? How are you going to solve it?
Wait, 1 and 2. Oh,
Same thing as plain David.
oh, I got it. 81 divided by 4 first.
Okay, well, first, what do you got to do before you do 81? What's the first thing you got to do? When you're playing what's under the cup, what's the first thing you got to do? Take away same on both sides, right? So I got to take away the 1 from over here, and I got to take away the 1 from over here. Just like when you're playing what's under the cup. It's the same thing. It's the same, exactly the same thing. Just bigger numbers. Now, what's 80 divided by 4? Oh my goodness. Is that a hard question?
Wait, 81 divided by
What did you just hear what I had to say?
80.
Did I just tell you you got to take away the 1 first? All right. Now, take 80 and divide it into 4 parts.
80, 20s.
That's it. Done. Oh my goodness. Isn't 4 times 20, 80 plus 1, 81? So they had to work for 20 hours.
20 hours. At least
That's
not,
like half a week.
at least not 24.
Yeah, but that's like half a week. You would have to work, right? Because if you work 4 hours a day for 5 days, that's 20 hours. So you have to work 1 8-hour day, another 8-hour day, and then a half of an 8-hour day. So it would take them 2.5 days to fill their order.
Wow.
Because they could only make 4 cakes an hour. So you know what they should do? They should probably figure out how to make more cakes an hour. Okay, so we're gonna go to a new factory, and they're gonna make.
What if they work 24 hours?
Oh, what if they did work 24 hours? You tell me.
Wait, can you give me another question?
I'm about to, but first, David wanted to know how much you get if you work for 24 hours. If they work for a whole day, let's say they all got hopped up on amphetamines and they didn't go to sleep and they just made ice cream cakes for 24 hours straight.
And then went to bed.
And then they went to bed. But first they worked for 24 hours. How many cakes would they make?
Yeah, just one. Okay. Let me answer it.
How many?
2 cakes. Wait. 24 times 4 first.
There you go. Plus 1.
24.
David, what's 4 times 2?
4 times 2 is 8. 97.
There you go. Is the right answer. 97. What? Because 4 times 2 is 80 plus 16 plus 1. 97. Done. All right. We're going to a new factory where they they're gonna soup up their machinery, and now they can make more cakes per hour.
I just have one thing. How
What?
many workers will there be if they can make if they can make 13 cakes in 3 hours? How many workers would there be?
How many workers would there? I can't tell.
What's your favorite food?
What's my favorite food?
Yep.
Steak.
You know what's ours?
What?
Durian. Or rather,
Durian.
our
No.
favorite food is durian.
No. So you like to stink up the neighbors? So that the neighbors tell you have to eat it at the park or something?
No, but
In fact, I think it's illegal to eat durian in public, isn't it?
Yeah, you can't bring it in the MRT or something.
Yes, you can't bring it on the train. Of course not.
until
Oh my God.
unless
They have people throwing up. Anyway, but you guys eat durian, really?
unless
girl-
in an
My
egg-
girlfriend likes durian. She'll eat durian. I'm not keen on it. I'll eat it because once you get past the smell, it's actually pretty tasty. But that smell is something else.
You know what's my third favorite fruit?
What?
Watermelon.
Oh yeah, there you go. Mine too. I like watermelon.
My second favorite is mango.
Oh,
I love
I used
those.
to have 3 mango trees in my yard when I was a little boy. So I always had fresh mangoes. So I have a hard time going to the store and buying mangoes because they're so terrible. Once
Yeah,
you're
Good.
used to picking them off the tree, getting mangoes that they pick green and then shipped in a container. Anyway, all right. I'm going to say, again, Mui doesn't get there on time. So we don't know how much they started with. But after 5 hours, there was 38
Three, is it?
cakes in there. So you can see they're making cakes faster than before. And after, we'll say 7 hours, dividing by 2, we'll make it 8. So they have to divide by 3. And then we'll say that's 59. And then if there was 73, how many hours were they working?
Okay, I got this.
All right. Yes, you do.
DY.
So what do you got to do? dy dx.
And then wait. 3 over.
Another way you can do it, David. What's the most amount of 5s I can count out of 38? What's the most amount of 5s I can count out of 38?
38. Wait,
Yeah.
10, 15, 20, 25.
Is it 3
30.
over 23?
You can count 7 5s.
7. I like it. That's how many 8s can I count out of 59?
8, 16,
I like it.
You can count 7.
Oh, so you can count 7 and you can count 7.
So-
Oh, okay. Wait. Vivian, you crazy monkey. Look over here. What
So
is
they
59
must have
minus 38? What is 59 minus 38?
They must have started with 7 then.
Oh, come on. Bruh, this is too easy. 59, and the number's even bigger. You don't have to borrow it to do anything. 38, what? I can go either way. What? 2, 1. Oh, what? 1, 2, what?
Wait, I saw 56. I mean 36 instead of 38.
Well, it's 38, you silly person.
Okay, so it's 21.
Uh-huh.
And then if it's 20, wait, where am I? Oh, okay. So they make 7 cakes an hour. Oh no, they started with 7.
Wait a minute. They make 7 cakes an hour. What's wrong with you?
No, they started with 7.
How would they start with 7? How do you know that?
Because they have machines.
How do you know that they started with 7?
Didn't you say they were machines, right? Or no?
Well, yeah, I'm sure they make it with machines. But look, David and me already figured it out. David and I already figured out that it was 7 per hour a week ago.
Oh.
And what did you do? Well, what you did is you said, okay, I got to take this minus that and get 21. I got to take that minus that and get 3. And so, yes, the answer was 7. And then what? It's 7 per hour. So after 5 hours, how many would they have? 5 times 7 is what?
35.
But it's not 35. It's 38. So how much more does it need?
3. So they started with 3.
There you go.
So they started with 3, but they make 7 cakes an hour.
Yes. And now, how long did it take them to make 73?
7.
Oh, come on. How easy is that? You're making me crazy.
No, I know. I have the formula already. So, so 73 is the same thing as 7x plus 3.
Correct.
So now
X
I
must
take
be
73 minus 3, which is 70, and then divided by 7, which is 10. So they took 10 hours.
You are correct. Now look over here, Vivian. I am very happy with you doing all your formula, but all you had to do is look over here and go 7 times 10 is 70 plus 3. Done. But you still got it, right?
Can we do
Right. Now let's do another one. Now here's the thing, Vivian, pay attention. Me and David probably going to beat you again because we figured out a faster way to do it even. dy dx works great. I like it. Right? dy dx. This is pre-calculus right here. This is your beginning function. Anyway, and now what is that? That's the rate, right? That's how fast they make it. Okay, when we start doing algebra and putting this on a graph, that's going to be the slope. And what that is over 1 up 7, right? Every hour. And wait, we got to start at 3. We don't start at 0. So I start at 3, and then I go over 1 up 7, and then I go over 1 up 7, and I go, that's going to actually would probably be steeper than that. Especially if I did it like that. So yeah, it would have to be like boonk way over there and then boonk way over, right? And that's what we had. We'd have, and then we could just draw our line. And this line, the formula for that line is y equals 7x plus 3. This is, we'll label the point 0.03. And then we got to put, this will be y, this will be x. And then we could plot a graph of our, right? Because the other one was 4x plus 1. So we start at 1. And can you see that over time, right? That this one is going to make a lot less time. It'll make a lot more cakes because the slope is greater, right? The rate is higher. Okay. Those will be a future lesson. For now, let's say they get a super duper upgrade.
Wow.
Yeah, they get an upgrade and 4. I'm gonna pay for this later. Oh, hold on a second. Okay, let's do. Okay, this is a super after. We still don't know because one more time he didn't get there on time. So at 0 we don't know. Oh wait. Yeah, at 0 we don't know. But we do know that after only 2 hours, they only work for 2 hours. They already got 28 in there. Holy cow! And then after, then I want to know what after 5 hours, how many would they have? And then I'm going to tell you after 6 hours, they have 76 cakes in that factory. They get full automation going, man. They got robots and everything.
Must be a very big factory.
Yes. They're knocking out ice cream cakes like you can't believe. Oh, wait. And then one more question. And I'm going to make this one better. How long would it take them to make 148 cakes? Dun, dun, dun.
That's a lot.
But if they have a huge amount of factory works, and it's a huge one, must take a while.
Mm-hmm. Now, here's the thing, David. On this one, our method of counting out twos won't work.
And mine
Because I can count 14 twos, but I can't count 14 sixes.
wait, mine will work.
Yours will work. Yes, it works every time.
Yeah.
dy dx, and then figure it out. So, David, what is 20 or 76 minus 28? So you got to get to the point. See, you get slack because you're 9, but you got to get to the point where you can do it in your head easily, right? So
48.
it is 40. How much?
48.
Okay,
How many a day?
48. And then what? What's the difference between 2 and 6?
So they make 48.
Wait. That's the difference. What's the difference between 2 and 6? Oh, come on, David. What's the difference between 2 and 6?
12 cakes per hour.
Okay, because it's 4, and yes, it's going to be 12. They make a dozen cakes every hour. So wait a minute. If they make a dozen cakes every hour, how many do they start with?
They
The difference between 6 and 2 is 3.
You're crazy.
Wait a
The
second.
difference between 6 and 2 is 3.
2.
I have a severe problem with that statement because it's false.
They started with 16.
4.
4.
Wait a second.
Did they start with 16?
How could they start with 16?
Wait. I'm wrong also.
All right, so wait. If they make 12 an hour and they work for 2 hours, how many should be in there? Vivian,
Oh,
if they work for 2 hours and they make 12 per hour, how many would they make?
sorry, it's 4. They started with 4.
How come? How do you know?
Because 12 times 2 is 24, and 28 minus 24 is 4.
There you go. And what's 6 times 12?
6 times 12? 60.
David, what's 6 times 12?
6 times 12. 6, 12.
6, 12.
Oh.
6,
6, 12.
72.
72 is the right answer. All right, but it's 76, so it has to be 4. All right, so they work for 5. So what is my formula? The amount of donuts, Y, is the same thing as they make 12 an hour, holy cow, and they started at 4.
60.
So after 5, they would have how much?
60.
How much?
60.
What happened to the 4?
64.
Oh,
Why? Because they started with 4, so after the 4 is still going to be there. And she's right. 5 times 12 is 60. All right, so now how long does it take to make 148? Dun, dun, dun.
Oh, I know.
How much?
Let me do my last step and I'm done.
Okay.
Oh, the answer is 12.
The answer is 12. Good job. Fine job. I think, you know what I think?
Yep.
I think we went past time.
Oh yeah.
But what about 20 hours?
What about, how much would it be after 20 hours?
A lot.
A few thousand.
It wouldn't be 1,000 yet. We only have 20 hours and only making 12. To get 1,000, that would be a long time. That would be like months worth of work.
But with the machine?
Even with the machine, only making 12 an hour.
No, at 1,000?
Wait, I'm gonna do the calculation.
Well, just for fun, do the calculation. Exactly. 1,000 equals 12x plus 4.
So after
12
days.
Oh, hey, we didn't figure out this one. What's 20? Well, 20 is going to be 240 plus 4.
1,000 times 12 is 1.
Wait. 240 plus 4, 244. But wait. We got to do this. 1,000 is, right there, is the same thing as 12x plus 4.
I know the answer is 1,204.
You're crazy. What I'm saying is I have 1,000 cakes and I make 1,000 cakes. It takes me 12 hours, or excuse me, I make 12 cakes per hour. I want to know how many hours.
Oh, I thought you meant
10 hours. Wait. After 10 hours, it'd be 120 cakes. So it's going to be more than 10 hours. After 100 hours, too many, because that would already be 1,200 and we only have 1,000. So what would it be? Well, I got to take my 1,000 and divide it by 12. But you can do that on your own time. We're out of time. Okay, you guys did a good job today. The only thing, like I said, you just got to practice your multiplication. And then we should have started off class building some tens and getting your brains warmed up, but we dive right into questions. So let's see. What do? We figured out how to convert Celsius and Fahrenheit.
Yep.
And what else did we do? Then we figured out the donut factory, right? And this is pre-calculus. This is high school algebra.
Next time.
It so happens that we're staying easy because we're keeping the numbers whole. But later on, we could just as easily do 3.5 or 1.5 or 2.5 or whatever, and make it fractions and decimals if we wanted to. But for now, because you guys are little and we're just starting off and you're getting the concepts down, we stay with whole numbers.
Next lesson.
And the idea is to understand the algebra of it. And then one more time, look, we could graph this. So here's what I'm going to do, Vivian. I'm going to give you homework. I always send your mom the video, right?
Yeah.
So watch the video and graph all the problems.
For pre-calculus?
Yeah, just graph them. Just do this. And then, you could use the same one. You could use the same graph and put all the lines on the same graph.
Question. Can we do a Coca factory next time?
A Coca factory? Sure. Now, what are they going to make? Coca-Cola? No.
Chocolate.
Chocolate. Okay, so they make chocolate bars. Yeah, okay, that sounds fun.
With huge machines.
Yeah, it'll be great with chocolate bars.
It's
Okay.
at least 1 km long.
Okay. Excellent.
1 km from there to there. 1 km from
So
there.
you're making kilometer-long chocolate bars.
And 1 km high.
Oh, here's the thing. Yeah, there you go. But wait, it could be 1 kilometer long, and then you would have to chop it up into little pieces to make your chocolate bars. But that would be a heck of a big factory to make a kilometer-long chocolate bar.
No, the chocolate bars are normal size, but the factory size is
Like
1
1
km.
1 km this way, 1 km that way.
Okay. And then, we'll talk about more about that too. We can talk about area and all kind of stuff. Okay, like I said, you guys did great today. I'm going to end the recording. CrewTenRamon'sHouseOfMath.com is how you do it. We just play, and lo and behold, they learn math. And today we didn't even hardly play with blocks. We just played with concepts and then how to write it down on paper. Anyway, CrewTenRamon'sHouseOfMath.com for more.